Okay, so again, what you've got to do is you've got to figure out with P of 2 that's telling us that our x value is 2, so where does x equals 2 fit? So if you check those numbers, 2 is between 0 and 40. And so since it fits into this part of the inequality, we have to use 8x for a function. So when we find P of 2, we're just basically plugging 2 into this part of the function over here. So they ask you to evaluate P of 2. P of 2 would equal 16. Okay, and that's a matter of just figuring out wherever this thing will fit based on whatever numbers it is that they give to you. So the big part is they ask you to find or ask you to evaluate P of 100. It's the same thing. Where does x equal 100 fit? Because they're telling us that's our x value here. And so for that part, with our two inequalities here, 100 is greater than 40. So then that means we're going to use the 12x plus 160. And so when we find P of 100, we're going to take 100 and plug it back in for x. Okay. And that's pretty much what you're going to do. So you've got different pieces of a function that's going to tell you, what to do with those pieces, and you're just trying to figure out which piece it fits into. The big thing you've got to remember is that no matter what you do, is that for each value of x, you only get one answer. All right. So, and if you have something that has, let's say you had something back here in the beginning on this one, that let's say that instead of having two pieces, it had three pieces. So we had a function that looked like that. You have another range where maybe this is x would be less than 0, and this was like 7. So if you had something like this, no matter what you did, if they ask you to evaluate p of negative 20, well, anything less than 0 would put you here, and no matter what happens, that answer is always 7. So if it's negative 1, basically any negative number you plug in here, it says this answer is always going to be 7. So the negative 20 would definitely fit in. For where does it fit? Well, x is definitely less than 0 because negative 20 is less than 0. And again, anytime there, no matter what number you plug in, the answer is always just going to be 7. So when they ask you to evaluate p of negative 20, the answer would just be 7. Okay, so that's regardless of any number that you're putting in with that one. Okay, so piecewise functions, again, the main thing is that you get one answer and only one answer for every value of x you plug in. Even if it's got three pieces, you just have to figure out which piece it fits into. And whatever piece it fits into, then use that part of the equation to then go back and evaluate it. Because I think the biggest mistake I've had people make is they'll see something that's got three parts and they try to give me three different answers. But again, you just got to figure out which of these pieces does the x value they give you, where does it fit? And you're either going to use this one, or that one based on what the values of x are that you're going to use. Okay, and then the second part of the lesson is we're doing something, still dealing with functions, but it's a different little piece of it. This one is going to be average rate of change. And with average rate of change, that's just a fancy version of slope. That basically this one is slope for functions, if you want to kind of think about it that way. And the biggest thing for this one is that when they talk about the average rate of change, if we want to just say this for short, if we call it AROC just for short of it, that basically for this one, it looks something like this. That when we did slope, instead of y2 minus y1 and x2 minus x1, this one is basically replacing the y2 and the y1 with f of x1 and f of x2 for this part. The big thing here is you've got to evaluate the x1 and x2 values to plug into the average rate of change function. Okay, so the big difference on this one is that when we did slope, they gave you y2 and y1 and x2 and minus x1. For this one, you're going to be given x1 and x2. You have to take those two numbers and plug it back into the function to then figure out what these two things are. Okay, so here's what we're going to do. Here's what the example would kind of look like. So it's going to ask you to find the, again, just for simplicity's sake, instead of saying average rate of change, we're going to call it short here. Find the average rate of change. We'll call it AROC for, and we just got finished working with some absolute value parts of it. So let's say we're going to find it for f of x equals absolute value of x plus 2. And then they're going to tell you when x1 equals negative 2 and x2 equals 0. Okay, so that's the big difference. You've got x1 and x2. So basically, you've got to figure out what f of x1 is and what f of x2 is by plugging in these numbers one at a time into this function. So if you're given f of x equals absolute value of x plus 2, you want to plug in this value of x1. So you're going to find f of x1 by plugging in this number at x1, so we're going to find f of negative 2. So that's the absolute value of negative 2 plus 2. So that's 2 plus 2, and that's 4. Okay, so f of negative 2 is 4. So when we go back to this equation back up here, or f of x1, really if we want to look at it that way. So where we've got f of x1 in this formula back up here, we can take that number and replace it with 4. Okay, and we're going to do the same thing with the x2 value we've got. And we're going to plug in this time 0 for x2. So we're going to find f of x2, which in this case means we're going to find f of 0. So absolute value of 0 is just 0. And 0 plus 2 is 2. So when we find f of x2, which again was 0, then that's going to equal 2. So in our formula, it's f of x2 minus f of x1 over x2 minus x1. So we're going to go back and plug in these numbers. We already know that x1 is negative 2, x2 is 0. 0 minus negative 2. And again, to get f of x2, that's where we took this number and plugged it in. So the f of x2 was 2. F of x1 is where we took this number and plugged it back in. That's 4. So that leaves us with 2 minus 4 and 0 minus negative 2. 2 minus 4 is negative 2. 0 minus negative 2 is 0 plus 2. So that's 2. So negative 2 over 2 is negative 1. Okay, so it's still finding slope, but the big difference is that you're giving x1 and x2. You've got to go take these two numbers that you're given, and you got to take those two values that you have and plug them in one at a time into the function, so that now you've got, when you plug in x2, that gives you f of x2. For this number to plug here, this was x1. We plugged it in to work it out, and that number goes in for x1, or f of x1. So it's still finding slope. You just have to figure out what these f of x values are when you're given these two numbers that's here.